It is moderately soluble in cold water but freely soluble in hot water. Amphoteric means those oxides will be having acidic in and as well as basic in nature. Depending upon the pH of solution, chromates and dichromates are interconvertible. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Now I am going to start session 3 from the chapter D and F block elements. In the previous session we have discussed trends in properties of transition metals of first series like oxidation states, metallic properties, alloy formation properties, interstitial compound formation properties and magnetic properties. These are the properties which we have discussed in the previous session. In the current session, we will discuss about some of the important compounds from D block elements, that is potassium dichromate and potassium permanganate, its preparation, its properties and also its importance. First we will see potassium dichromate. Before going to the important compounds, we have to understand that the metals with lowest oxidation states having the acidic nature and the metals with having higher oxidation state will be having basic in nature, and some of the metals are amphoteric or some of the metallic oxides are amphoteric in nature. Amphoteric means those oxides will be having acidic in and as well as basic in nature. Okay, here metallic oxides will be in the form MO, MO2O, MO3O6 etc. These are the oxides formation from the metals, and those oxides with higher oxidation state will be forming basic oxides, and those oxides with lower oxidation state will form acidic oxide. These are the major points you have to analyze or you have to understand before going to the important compound. Now we will move on to the potassium dichromate. Its molecular formula is K2Cr2O7. Okay. Preparation, we will see potassium dichromate is prepared by the following step. In the step 1, the chromate or FeCr2O4 is fused with sodium carbonate or soda ash in the presence of air to get sodium chromate. Sodium chromate is extracted with water and filtered. This is chromate ore treated with sodium carbonate in the presence of air, and it will form sodium chromate. Okay, it will be extracted with water and filtered. In the next step, the yellow solution of sodium chromate obtained above is acidified with H2SO4, that is sulfuric acid, to get an orange colored solution of sodium dichromate. Whatever here sodium chromate with yellow color solution it will be formed, it will be treated with or acidified with concentrated or dilute sulfuric acid, and which gives a orange color sodium dichromate compound, okay, with sodium sulfate and water. Sodium dichromate solution is concentrated and cooled. Less soluble sodium sulfate crystallizes out first and it is filtered off. That sodium dichromate solution will be concentrated and it will be cooled. Sodium sulfate is having crystallized out first and it will be filtered off. In the step 3, the above solution of sodium dichromate is now treated with potassium chloride when the orange crystals of potassium dichromate, which is less soluble than sodium chloride, precipitate out. This sodium dichromate will treated with potassium chloride and which is less soluble here. So potassium dichromate will form and crystallizes and precipitate out with the liberation of sodium chloride. Okay, there are 3 steps. Once again, chromate ore will treated with sodium carbonate in the presence of air. Here sodium chromate will form. That yellow color sodium chromate will be treated with or acidified with sulfuric acid and it will form sodium dichromate, and that sodium dichromate will be treated with potassium chloride, which is that sodium is very much lesser than sodium, so it will be precipitate out as potassium dichromate and sodium chloride will be filtered off. This is the preparation of potassium dichromate with 3 steps. Physical properties. Potassium dichromate is an orange-red crystalline compound. It is in the color of orange-red crystalline compound. You know, in the solids, two kinds, crystalline and amorphous, but this potassium dichromate will be in crystalline in nature. It is moderately soluble in cold water but freely soluble in hot water. In the cold water, it will be moderately soluble, but in hot water, it will be completely soluble. These are the two physical properties of potassium dichromate. Next chemical properties of dichromate. Action of heat. On heating strongly, it decomposes, liberating oxygen. Okay, when potassium dichromate heating strongly, it will be decomposes into liberating oxygen. It will liberate oxygen and it will decompose. This is potassium chromate and this is chromate ion. Then interconversion of chromates and dichromates. The chromates, dichromates are interconvertible in aqueous solution depending on the pH of the solution. Depending upon the pH of solution, chromates and dichromates are interconvertible. On heating with alkalis, it is converted to chromate and the color changes from orange to yellow. When dichromate is treated with alkali, which is a base, and it turns orange to yellow color solution. Okay, if it is acidified with acid, the reaction is reversed and color again changes to orange. Okay, this is a base or an alkali converted into orange to yellow color solution. This is acid. If you use acid, it will be reversed from yellow to orange. This is how the interconversion of chromates and dichromates will be done. Next, it is having an oxidizing property, which is a chemical property. It acts as powerful oxidizing agent in acidic medium. In the acidic medium, it will act as very powerful oxidizing agent. The presence of dilute H2SO4, its oxidizing action is more. Okay, acidic medium is, it should have some acidic content. Majorly, acid will be used as H2SO4. In that, powerful oxidizing agent will be acting. Here, chromate plus in the acidic medium plus electrons. Here, chromate 3 plus and water will be liberated. Okay. Acidified potassium dichromate oxidizes iodides to iodine. Okay. It will act as oxidizing agent. So, in the acidic medium or acidified potassium dichromate oxidizes iodides to iodine. Here, this is chromate ion in the acidic medium. This is the first general reaction. By using this one, iodide to iodine will be formed. This is iodide and this is iodine. The overall reaction Cr2O7 2 minus in the acidic medium H plus and the electrons iodide to iodine with chromium and water. Okay, this is overall example and it has been seen by step here. Acidified potassium dichromate oxidizes Fe2 plus salt to Fe3 plus. Oxidizing means or oxidized means the higher in or increasing in oxidation state. So, 2 plus will get converted into 3 plus. See here, ferrous will get into ferric. Here, in the acidic medium, wherever H plus is present in the acidic medium, Fe2 plus will converted into Fe3 plus. This is the overall reaction. And next, it oxidizes hydrogen sulfide to pale yellow precipitate of sulfur. Here H2S2, S will be, that is sulfur will be converted. See here in the acidic medium, hydrogen sulfide will converted into sulfur. This is a precipitate of sulfur. These are the three examples of potassium dichromate which will be act as a powerful oxidizing agent in the presence of acidic medium. Okay. This is the structure of chromate and dichromate ion. This is in sp3 hybridization, chromate ion CrO4 2 minus. See here dichromate Cr 1, 2, 3, 4, 5, 6, 7, CrO7 and this is 2 minus. This is dichromate ion. Both are sp3 hybridized. That is single chromate. This is dichromate with 163 ecometer. Uses of potassium dichromate. Potassium dichromate is used as oxidizing agent in volumetric analysis. We have seen with numerous Examples: it is used in modern dyes, leather industry, photography. Okay, it will be used as dyes, dye industries or coloring industries, leather industries and photography for hardening of film, and it is used in chromyl chloride test. While doing the qualitative analysis of inorganic salt, you will do one chromyl chloride test where you will use this potassium dichromate, and it is used in cleaning glasswares. Okay, these are the 4 applications or uses of potassium dichromate in the major way. Next, potassium permanganate. Usually it will be in the pink color. That molecular formula is KMNO4. Potassium permanganate is prepared by fusion of manganese dioxide with potassium hydroxide in the presence of an oxidizing agent called potassium nitrate. The mass turns green with the formation of potassium manganate solution. Okay, this is MnO2, that is manganese dioxide with potassium hydroxide in the presence of air. It will form potassium permanganate with the liberation of water. The fused mass is extracted with water. The solution is now treated with acidic solution when KMNO4 disproportionates to give KMNO4, that is K2MnO4, and it will be treated with in acidic medium, so it will give KMNO4. Okay, see here in the acidic medium they are using sulfuric acid and it will form KMNO4 plus MnO2 and K2SO4, that is potassium sulfate or water. You can write in a other way also, that is MnO4 minus manganese oxide in the acidic medium. MnO4 will be given out MnO2 plus water. Okay, H plus is also termed as acidic medium. Here they have used H2SO4 directly. Commercially, it is prepared by alkaline oxidative fusion of MnO2 followed by the electrolytic oxidation of manganate. Okay, MnO2 fused with potassium hydroxide in the presence of air or potassium nitrate. Manganate ions will be liberated, that will be in green color. Then later electrolytic oxidation in alkaline medium. In the alkaline medium, electrolytic oxidation is being done. Purple color manganate will be produced. Okay, first MnO2 will be treated with potassium hydroxide in the presence of oxygen or air. MnO4 will be liberated. That MnO4 green color, after the electrolytic oxidation in alkaline medium, MnO4 minus, that is in purple color, will be liberated. It is by commercially. In the laboratory, Mn2 plus salt can be oxidized by peroxo disulfide ion to permanganate ion. In the laboratory, how it can be prepared? Acidic medium MnO4 in the, that is acidic medium H plus, and 5 electrons will be liberated. Mn2 plus will be formed. In the neutral or faintly basic medium, MnO4 in the water, MnO2 and OH base will be liberated. This is the laboratory method, how permanganate will be formed. This is commercially method. Okay, and physical properties. It is a dark purple colored crystalline solid. It forms dark purple rhombic prisms. And this is a dark purple colored crystalline solid. It is isomorphous with potassium perchlorate. It is fairly soluble in water, about 6.4 gram per 100 gram of water at 20 degrees Celsius. It is fairly soluble in water. At these conditions, 20 degrees Celsius, 6.4 gram per 100 gram of water will be soluble. These are the physical properties. Structure of manganate ion and permanganate ion. This is tetrahedral manganate ion in green color. This is tetrahedral manganate ion in purple color. Next, chemical properties. Action of heat. When heated, it decomposes evolving oxygen. Like potassium dichromate, potassium permanganate also, when heated, it will decomposes and liberating oxygen. Oxidizing action. It is also a very good oxidizing agent. Potassium permanganate is a powerful oxidizing agent. It acts as an oxidizing agent in alkaline or neutral as well as acidic solution. The potassium dichromate was acting as oxidizing agent only in acidic medium, but this potassium permanganate will act as oxidizing agent in all the mediums like acidic medium, neutral medium as well as alkaline medium. A few important oxidizing reactions of potassium permanganate are given below. In acidic solution, oxidation of MnO4 minus ion can be written as, this is in acidic medium, Mn2 plus will be formed. This is also in acid medium, iodide to iodine. See, iodide to iodine will be formed. And in the same acidic medium, Fe2 plus will be converted into Fe3 plus. Chromate ion or oxalate ion will be converted into carbon dioxide. Okay, here see, sulfur is oxidized to form H2 minus sulfide ion to sulfur. Okay, these are all the examples of where permanganate ion is acting as oxidizing agent in acidic medium. Here also sulfurous acid or sulfite is oxidized to a sulfate or sulfuric acid, and nitrite is oxidized to nitrate. Okay, these are all the examples of oxidizing agent which is a potassium permanganate in acidic medium. Next, in neutral or faintly alkaline solution, water is also a best alkaline solution. Iodide to iodate, and next trisulfate is oxidized almost quantitatively to sulfate, trisulfate to and sulfate. Next, manganese salt is oxidized to manganese dioxide, the presence of zinc sulfate or zinc oxide. See here, manganese salts to manganese dioxide. And its uses, it is used for the bleaching of wool, cotton, silk and other textile fibers, and for the decolorization of oils are also dependent on its strong oxidizing power. It is used in the textile industry like bleaching of wool, cotton and silk, also decolorization of oils based on the power of or strength of oxidizing agent. Okay, these are the some of the important compounds from D block elements and which are having the most powerful oxidizing property, and you have seen the preparation properties, also importance of those. So, in the next class, we will see about the F block elements. I hope you have understood completely whatever I have taught in this session. We will meet in the next session. Thank you.